start. I think we're going to get started. So we have Colleen Peters here today. She's the lead marine technician aboard the research vessel the FALKOR, operated by the Schmidt Ocean Institute. She helps plan upcoming science cruises and leads the onboard technical team to support the science party with their research. She's worked on 14 ships, both sail and motor, in the passenger sail training and scientific research industries. And her professional interests include seafloor mapping, learning how to deploy new equipment, exploring areas of the ocean for the first time, and training the next generation of technicians. So please welcome Colleen today.
Hello, good afternoon. Thanks for having me. I'm going to talk to you a little bit today about, a little bit more about who I am, what I have to do with any of this business, and what Schmidt Ocean Institute is, if you haven't already heard of us, the types of systems that we have for mapping on board the FALKOR, and then kind of what we've been up to over the last few years as we became operational, a lot of the different areas that we've been surveying. And then finally, I'm going to tell you a little bit about how you guys can possibly get on board. So, I graduated from Maine Maritime Academy, so not too far from here, and I studied marine science and small vessel operations. And what I discovered when I was in college was that I really liked doing science, and I really liked being at sea, working on boats. So becoming a technician was a really great way to combine both of those interests, because I get to do the really fun field work. I don't have to write papers, and I don't have to ask anybody for money. So, but my responsibilities on board are involved with cruise planning, so finding out what the scientists want to do when they come on board, making sure that any equipment they want to bring, we can integrate it, make sure it works, and then maintaining all of the science equipment we have on the ship, and if the case may be, to train the science party how to operate that equipment or process the data. So we take scientists on board from all over the world, and they'll come on board with a wide variety of experience and skill running whatever kinds of equipment we may be using during the cruise. So my duty really is to communicate between the science party and the ship's crew to make the efficient use of the ship to conduct the science operations successfully, and also to operate and maintain and then troubleshoot, even in the middle of the night, the science equipment and all of the lab spaces on board. So standing in the Horton office at Kongsberg one day during the training session, having my coffee, and I pick up their product catalog, and wouldn't you know, in front of my face was this map. This is my first map. And I thought it was really funny that it was in the product catalog, because it's not even really that good of a map. But it was kind of the start of my interest in sort of the mapping field. Because as a technician, I'm supporting a wide variety of operations, but this very quickly became the one that I was sort of most interested in. So I deal with all of the disciplines of the sciences, from the groups that come on board, conducting all different kinds of studies, but mapping is probably one of the most common because it's so useful for all of the disciplines. So what I really like to do, kind of as a pet project and a way to release some of my creativity, is I like to just make mapping products for the cruises that we're on. And these products, sometimes they're used for posters. Some of the posters I've actually made working on the NOAA Ship Okeanos Explorer hanging in you guys' hallways. But then they're used for presentations or conferences, all different type of stuff. And basically, I really just enjoy communicating to the public, what it is that we're doing and why it's important and meaningful. Because we all know kind of what's going on in the industry, but the general public sometimes doesn't even know we exist. So anything that I can do to sort of help educate the public is, I think, really beneficial to us all. So how many of you have heard of, or excuse me, let me jump back a second. My other sort of contribution, if you will, in the field came early in 2009 when we were first using the very first Kongsberg EM302 system. So with a lot of the other sonar systems, the workflow, I would say, for processing mapping data is fairly well established. But it really wasn't until this time where we had really figured out what to do with the water column. Water column data is more commonly, until that point, collected with other systems like the EK60, for example, really to quantify things like fish schools in the water column. But now we have this multi-beam system where all of a sudden we have this capability of identifying other stuff like seeps and gas plumes. And it hadn't really been quite understood, A, the quality of the data, B, the accuracy of the data, and then C, what the heck do we do with all of it? You know, do we turn it on all the time because it takes up a lot of disk space? Is anybody actually going to review that? How do we process that data? And then where do we even put it when we're finished? So finding this plume, this 1,400 meter plume just in the middle of nowhere off the California coast, was kind of a big turning point for that discussion. And it was just kind of exciting for me to be there and be part of that. Because after we discovered this plume, we discovered several more plumes in the area. And then as the ship traveled around to different parts of the world, continued to discover even more of them, now that we had an even greater capability with multi-beam than we did with single beam. So that's kind of a little bit about me and how I'm involved with this community. But I want to ask you, how many of you have actually heard of Schmidt Ocean Institute? Okay, so about almost half of you guys. So this is totally normal because Schmidt Ocean Institute was only founded in 2009. So compared to you guys here at CCOM and Woods Hole, Scripps, and all the other universities, we're a very young organization. So Schmidt Ocean Institute is a nonprofit organization that's privately funded, was founded by Eric and Wendy Schmidt. And this company was founded to provide not a competing platform, but an additional platform, meaning the ship, the RV FALKOR, for scientists to conduct research. And in particular, the types of projects we like to fund are ones that are not commonly funded by the federal government. So in particular, development of new technology. A lot of government funding agencies don't really want to fund engineering cruises because they don't know what results they're going to get. And it's hard for them to justify spending the people's money on projects that may actually have no result or may have a bad result if it doesn't work. But that's the kind of stuff that we like to do. We like to drive people to develop new technology, to figure out better ways, methods of making discoveries or analyzing data and discovering new things about the ocean. The other part of that is also the open sharing of the information. Because while we have the scientists that come on board, they have a project, some question they want to answer, or something they want to figure out, there may be other people who, when they get that data set, they may see it in a completely different perspective from a totally different angle and see something else also new. And so we want to make sure that the whole community can benefit from the use of the FALKOR and the collecting of whatever data sets we get during each of our cruises. The timelines for making that data available vary a little bit depending on the cruise, but it's pretty much a requirement for all of our cruises to share the data at some point. So I'm just going to kind of give you an overview of the mapping systems. We have a lot of other equipment on board as well. I figure this being the Center for Coastal and Ocean Mapping, this might be your big interest. So we had a very interesting refit of the ship. It took place over about 3 years. And the purpose of the ship really evolved quite significantly during that time. And it wasn't until pretty late in the process that they decided to add sonar systems. So I think that was a really great idea because, as it turns out, I think this really is our biggest contribution to the community is our mapping data. Because despite what other equipment or disciplines may be studied on the cruise, most of the cruises involve at least some mapping. So the sonars are pretty much always used in some capacity. So the multi-beam systems, the Kongsberg EM710 and 302 are the most commonly used. And then we also have the EK60. We have 6 frequencies there. We have 4 frequencies of single beam, 12 kilohertz sub-bottom, 2 ADCPs that don't work, and a variety of software to process all that data. So, as I said before, we get scientists from all over the world on the ship. And a lot of times they bring undergraduates who maybe have absolutely nothing to do with mapping, and they're just there to, help the team process some data and make the cruise happen. So then the technical team on board have to train the scientists how to collect the data and then how to process it. And as it costs a lot of money to operate these ships, for one sea day, probably on a very estimated average of, say, $40,000, we can't just go out there and collect some data and come home and then figure it out. We have to be processing the data as we're going along, probably as most of you have experienced. Make sure everything's working, everybody's happy, everybody gets everything that they want. So to do that, we have a variety of different softwares available on board, because a lot of the groups that come on board may not have any access to software, because they may not come from a mapping program. It may be a biology group that wants to study the coral habitat of some seamount somewhere, but mapping is the data set they need to do that, but they may not be the ones that actually have the experience with it, so they may not have those tools at their home institute. So that's why we help provide those as well on board. So we have a variety of different software, because in my experience working with all of these different groups, pretty much nobody does the same thing. So we'll have one group come in and they've been using an MB system for 20 years. It's what they know how to do, so that's what they use. We have another group who comes in who has no idea how to do anything, and if you don't know how to do anything with processing multibeam data, not really likely to start you off on MB system. It's not an easy program to use, in my opinion, and particularly because a lot of sort of generic science students, they don't really get command line experience in their programs. And if you don't have that foundation, it's even harder to try to get you to figure out how to use MB system. So we tend to start with programs like Keras, where you have a GUI and you can see icons and they make sense and there's a flow. Sabre is kind of a cross between the two a little bit, because again, you have to have a little bit of Linux experience in command line to kind of get into it. And then once you do, there's a GUI that you can use to see everything and do everything. So it's almost a little bit of a cross between, but Sabre is mostly used in the hydrographic survey, meaning to make navigational charts sector, as is Keras. But Keras is also used for a lot of scientific mapping just because it has that human interface. But the Keras licenses are really expensive, so that's why a lot of universities, I find, will use MB System because it's free. But no matter what your process is for ping editing, cleaning the data, one of those three tools are the most common. Pretty much everybody ends up in Fledermaus at the end of it, because pretty much everybody wants to have their nifty looking digital terrain model twirled around in 3D and make animations and fly-throughs and have all these layers and things they turn on and off, and then export to all these other formats for other programs like ARC and so forth. So it gets to be a little bit difficult trying to support all of these different types of software, because there's obviously lots of little things and nuances between each one of them. But we want to make sure that we have the tools available for the teams to use, whatever their preference is. What's interesting is that this previous year, we've got a new player on the market, which is Chimera. So Chimera and Fledermaus, I'm sure you guys are pretty familiar, it's developed by QPS. And while you can bring in raw data in Fledermaus and you can clean it up in Fledermaus, it's really not intuitive. It's not very easy to do, but they've changed that when they developed Chimera to have a really easy interface, a much simpler process. And where in the science mapping field, we use Keras does this and Sabre does this, and we use about this much of it. So there's just all this other tools and things functions that Keras can do that we really don't get into, because what we have to do is we want to bring in the data, see where it is, clean it up, and export it. That's pretty much what Chimera does. So that covers pretty much all the basics that we need to accomplish. But from my opinion, in a much easier package and a much easier tool to teach new people who have never done this before how to use. Where Keras, for example, could be quite nitpicky and quite finicky about certain things. Chimera is pretty much 1, 2, 3, 4, 5 done. So it's really interesting to see the progression of all of these different software packages and how people decide to use them. So the one thing that really makes the mapping systems on the FALKOR really successful, and allows us to provide really clean, high-resolution data as the gondola. And this is the fin-shaped keel structure that was attached to the hull during the refit. And this houses all of the sonar systems. So what this does is it allows bubbles that are formed at the surface as the ship's moving through the water to flow down the hull, but they flow down the hull above the transducers rather than below, blocking the sound. So, of course, we're not invincible, so we get to a certain point in the weather, it builds to a certain degree, you know, we will get bubble sweep down, but it's a lot higher than other ships with other types of installations. So we've found that a lot of the folks that have come on board have been immensely impressed with the quality of the data from the ship, because we have a little bit of a lower noise interference on the sonars themselves, and then a lower interference from bubbles. So this is what the gondola looks like, and although we have this really huge benefit of really clean data, the only downside is that it's a bit hard to access the equipment when the ship's in the water. So really to do the maintenance and to replace any of the transducers or anything, you really have to be in dry dock. And that, you know, typically is really only scheduled every two or 3 years. So, for example, right now, our ADCPs don't work, but we don't really have a great method to take them out to get them repaired. So we have to wait another year until we go into dry dock. So that's another year that we're without that capability. So that's something that we're starting to really think about, you know, how could we change that? How could we make that better? How could we make it easier to actually access some of the systems, get them repaired? So to go along with the mapping systems, particularly with the Kongsberg systems, you have to acquire your navigation and motion data in real time in order for that system to work. So our primary system is the Kongsberg Seapath 320, and then we also 2 years ago, or a year and a half ago, installed as a backup the Atlantic's POSM V. And for us, the justification really is, you know, if your Seapath goes out, you don't have a survey anymore. It will not work. SIS will not work. So we want to be able to make sure that we don't have any down days when we're out in the middle of the ocean, in the middle of nowhere, you know, having to turn around and go 4 or 5 days into port just to get some parts fixed. So the way that we have it set up is we have both systems permanently tied into the TRUs, so that all we have to do is go in the SIS software and reselect the active sensors. So it's a super quick fix if we need to switch to the other system, because when we do our annual patch tests, we do one version with the Seapath and one version with the POSM V. So we spend that 12 hours to do each of those, you know, at one time a year, rather than, oh shoot, now we gotta go find a place to do a patch test in the middle of survey. We don't really wanna do that. We don't wanna interrupt the science time with that. So we try to be as prepared as possible. So we have both pairs of antennas all the way at the top of the mast, and we have the MRU on deck 2 and the IMU on deck 3. So then the other part of the Kongsberg systems is you need to also have the sound velocity going into the systems in real time. So we have to have the sound velocity probe and then updating our profile. So what's really great about our sound velocity probe is that it's actually in a tube. And so the sensor itself sticks out of the ship's hull just forward of the gondola, right here. So what this does is it allows us to be able to inspect the probe if there's a problem. So we'll be in the middle of a survey, we're not getting data, what's going on, just unbolt it, pull it up, find out what's happening, replace it or fix it, put it back in, boom, ready to go. This is really great in one case when we were transiting on our way to Pohnpei. We're just kind of mapping, going along, boom, no data. What happened? What's going on? We try a couple things, wiggle some cables, you know, that doesn't help. Go down there, pull the thing up, take a look at it. Just in case you're wondering, if you ever run into this, you do not collect quality sound data when there's a squid in your probe. Thankfully, this was like the world's easiest troubleshooting for once. So that was pretty exciting. Nice, quick, easy fix. It took us longer to find the wrenches to get the bolts off than it did to actually fix the probe. So that was good. So we have a couple of methods available to us. Now, when we're doing multidisciplinary cruises, like we're doing an oceanography cruise, you know, and doing a lot of CTD casts, we'll use the CTD for our sound velocity profile. If we're doing just a mapping only, we'll at least take a CTD profile at the beginning to get a full ocean depth profile and salinity profile in the area. And then from that point on, we'll move to the XBTs, because then we can use those as we're underway, as many or as few as we need. We also have the sound velocity profiler, which is internally logging, so if the stuff really did hit the fan, we couldn't deploy our CTD or the XBT fell overboard, we could deploy that, on a piece of line or something, or put it on some other package that we're deploying. So we have lots of options. And then when we have ROV cruises, we tend to use the ROV CTD profiles as well. So anything we can do to sort of minimize the time spent doing this extra data collection works out to be more efficient. The thing that really, I think, helps the most with all of that is the sound velocity profile editor software developed by the Multibeam Advisory Committee, because this allows us to take whichever profile instrument we're going to use, bring that in, take a look at it, clean it up, and then send it over the network to the Multibeam systems. You're done in like 5 minutes. So that makes it really easy for us to just update that as many times as we need. So I'm just going to go over what kind of we've been up to as far as some of the survey areas that we've done and the different parts of the world that we've been in. I'm not going to go into super scientific detail. I can certainly answer questions afterwards. And you can read a lot more about any of the particular projects on the website. We have blogs for pretty much every cruise. So if you want any more specific details, we can find them on the website as well. So we commissioned our sonars in 2012. And when we went to do our first commissioning cruise, we didn't quite accomplish everything we wanted, so we decided that we needed to sort of repeat some of the exercises in a different area. And so we decided, well, why don't we do this in an area where we might find a shipwreck? How neat would that be? So we went to Greenland and actually got permission to conduct a survey in their waters, where, based on a bunch of research by one of the other technicians, we suspected the SS Terra Nova had sank. And the SS Terra Nova is really important because it was one of the 2 ships competing for the South Pole. So the Norwegian team with the Fram, they won inevitably. The Fram is now in a museum. The Terra Nova for the British team went back into its commercial service after the race to the pole, and it sank mysteriously off of the coast of Greenland. And we found it on our 3rd line of data. We didn't realize that for about 10 more hours, but then we went in with a little towed camera and identified it. So that was a pretty successful way to start our mapping career, if I say. So the ship then crossed over towards the US and went down to the Gulf of Mexico, did a bunch of studies of artificial coral reefs here off the coast of Texas, and then studied some of the seep areas around the Gulf of Mexico, like the Deepwater Horizon site and a couple other nearby areas. So we got lots of practice mapping seeps. And then our first science cruise of 2013, 2012 was sort of our commissioning sea trials year, if you will. 2013 really started the official science cruises. This was the Campeche Escarpment Cruise, and this was the first set of multibeam data that was made available in NGDC and then also in Google Earth. And this was processed by the guys over at Mbari. Dave Carras was on board for this cruise, and him and his team, processed pretty much everything on board, and then only really had to tidy it up when they got back to shore. So this data set was made available very, very quickly. The ship then went down to the Caribbean and did some work off the Mid-Cayman Rise looking for hydrothermal vents. And I don't know if you would recognize this from earlier, but I had a map that I did of the same area. So I had been there on the Okeanos Explorer in 2010 or so, 2011. And so several ships have gone to this area, and each time a different ship goes, they sort of add on to that map. So FALKOR really added on to stuff that the Okeanos Explorer had done previously and other ships before them. Then the ship was headed to the Pacific, so they made a little pit stop off by Roatan, because this is an area where not too many ships really go. So it was really kind of a crucial little ancillary project for them to be able to map this area off of Roatan, because they wanted to establish a marine sanctuary, but they can't do that without having some sort of idea of what the topography is like. So the ship came through the canal, went up to Canada, did a bunch of surveys up there, and the significant piece here was just finishing off Barclay Canyon, because Ocean Networks Canada was doing, has a couple of Coast Guard ships that they use to do their surveys, or very frequently the University of Washington Tommy Thompson. So they don't really have that many vessels that they can use up in that area. So we were able to sort of finish off a section of the canyons that they didn't have. So now they have the full extent of Barclay Canyon. The biggest contribution as far as just size of survey that we've done so far has been in the Papahanaumokuakea Marine National Monument.
Say that again?
Papahanaumokuakea. Practiced it for like weeks before that cruise. And so this is a really significant cruise, because it was 2 36-day legs mapping only. So we covered an awful lot of ground. And because we have the 302 and 710, we focused on depths between 50 meters and 4,000 meters, because if we really did anything less than 50 meters, I mean, with our swath width, it would have taken, 10 years to do. But a lot of these areas, like on the atolls, are already mapped by ships like the Hialakai. So we tried to focus on sort of the area where you have the most biological habitat, because then once we get below 4,000 meters, then it's also not efficient for the 302 system to be mapping, where the Kilo Moana, for example, has an EM122, and they would get much wider swath coverage in these depths. So we leave that for them to figure out some other day. But in those two cruises total, the FALKOR mapped 35% of the monument. And this was a really important sort of example of one of our founders, Wendy Schmidt's sort of classic statement is, we can't protect what we don't know. So when we're talking about ocean health and sanctuaries and stuff, a lot of the monument is not mapped. We have no idea what's there. Well, how do we know what to do about it? How do we know what to regulate or how to protect that area? We don't actually know what's there. So we've made a pretty good contribution towards that. And then, of course, the Okeanos Explorer has been back or going back, and the Kilo Moana and the Hialakai and the SETI and all the other Hawaiian located ships also continue to contribute towards that. But this was a really pretty good dent in that, and discovered a couple of really interesting new features in those cruises as well. So then we went down to the Ontong Java Plateau, which we studied the Cronky Canyon, and so the idea was to find the extent of that canyon and to try to find its source, thinking like maybe it came, kind of stems from the Nukumanu and Ontong Java atolls, but it was a bit hard to find because, once we get, again, to this shallow of a depth, it really is an inefficient use of this ship's time because the swath width is so small. So we did a couple of reconnaissance lines trying to see if we can get an idea of where it was going, but we kind of ran out of time and wanted to make sure that we got kind of the whole width of the canyon done. So we had a UNH student here on this cruise, Tomer Ketter, some of you might remember. So then we were headed for Guam, and I looked ahead and noticed we'd be going over this really deep hole. So I decided, hey, let's see what the sonar does. When I went over the Mariana Trench and the Okeanos Explorer in 2010, that was the first time the EM302 was used in that depth. But in the SIS software, Seafloor Information System, there's actually a hard-coded maximum depth limit of 8,000 meters. So no matter, even if we wanted to try an extinction test, we physically couldn't. The software wouldn't let us. So we would get data down to 8,000 meters, and then we'd just have a big black hole because it just wouldn't do anything. And so we got Kongsberg to fix that, so they made the maximum depth limit like 11 or 12,000 or whatever it is now. So this time we left it wide open, drove over the really deep hole just to see what we would get. And when, we were still getting data down to like 9,700 meters, which was really interesting because nobody expected that to happen with a 30 kilohertz system. Of course, the data quality is a little bit narrow at this point. Unfortunately, this is a transit, and I only could slow down to 8 knots. I would have preferred to go maybe 4 knots to try to really get some good soundings at that depth. But it was a bit of a compromise between trying to get to port on time and doing our little experiments. But it was just really interesting to see the sonar really could map a lot deeper than people expected, because the sort of announced range for that system is really down to 6,000 or 7,000 meters. They don't advertise that it can go really any deeper. So knowing that, going on the next cruise to explore areas around the Mariana Islands and the Trench, a couple of new seafloor features were mapped, this one being the maximum depth of 8,700 meters. So this was something that, back in 2010 when we tried this on the Okeanos Explorer, we wouldn't have been able to do, because we would have had that maximum depth of 8,000 meters. So the FALKOR seamount was just recently accepted as an official title for this feature, as was the Engineer's Ridge, which was named for the unsung heroes, meaning the engine team keeps the ship running and keeps the science happening. They really are, and on FALKOR, I have to say, I've never sailed with a better group of engineers. They make miracles out of absolutely nothing, so this really is a good tribute to them. So Engineer's Ridge was also recently accepted as an official name. The ship then went down to Australia, and the interesting thing I find about Australia is it's, ginormous, but they have 2 ships. And I just find that fascinating. Two research vessels and some Navy vessels, and then they have this whole other commercial fleet. Where here in the US, I think we sometimes don't really appreciate that we have like 20 UNOL ships and 20 NOAA ships and a couple other private ships. We have quite a large fleet of ocean-going, oceanographic science vessels, and so there's so much the planet that's not explored just because there aren't resources to go there, So the ship went to Australia to explore Perth Canyon, and this canyon is like on their doorstep. It's not far away, but they just don't have any ships to go out there and really do the scientific work. So this was the first high-resolution map of the canyon.
It's not the first attempt.
Not the first attempt.
First CBeam 2112 sea trial was done in that canyon.
Yep. There was a bunch of
Data
other
wasn't that nice.
previous data, but yeah, the quality was, this is actually not a great image of the data, but you guys get the idea. So then we continue around to Indonesia, the west coast of Sumatra, where we were studying the area of the Mentawai Gap region, which is where there was the really big earthquake that destroyed the coast of Sumatra. And what they wanted to do was to take a look at the area and see if they could identify differences between pre and post earthquake events, and then also other areas that might potentially, if they have an earthquake, generate tsunamis, just as a way to sort of not make a pre-warning, but sort of get an idea of, what areas could be possibly affected by these kinds of events. So this past fall, the ship went off to the northern Pacific, kind of just south of Japan, and did a mapping survey over the world's largest volcano, Tamu Massif. And this volcano is so large that there would have been no way that they could do a survey in the time allotted, which is about 25 days, to have overlapping lines. So what they did is more of a reconnaissance style, where they just wanted to find out sort of the extents of the volcano and then get, a better idea of the features on the volcano in a little higher resolution. And then on top of that, they towed a magnetometer so that they could identify the magnetic anomalies associated with the topography. So this past November, December, we did a cruise off the Mariana back arc, and this was to look at hydrothermal vents in that area. And so you have the Mariana chain, and then just to the west of that is the back arc. And this area has been mapped pretty well. We did a bit of filling in, and then we also just remapped a couple of areas as we're going by, and we found some interesting things. Now, this is a case where we have a multidisciplinary cruise. So the objective was to find vents. So we map the area, we find some interesting targets, and then we conducted a TOYO with the CTD to try to find some plume activity, sniffing it out with the sensors on the CTD. And then from there, we had the AUV Sentry on board, which then would go down and do a higher resolution map of the area and or do photo mosaicing as well. So this was an area where we found some vent activity, and first indicated by the mapping, then indicated by the CTD. And then when we did mapping with Sentry, we found that there was a difference within the last 2 years of the bathymetry. So there was a change. So we sent Sentry down to go take a look at it, and you can kind of see these white lines here. These are sort of highlighting the areas that had a surface difference, and that's where Sentry surveyed and found new lava flow. So that's new within the last 2 years since that area was previously surveyed. So now I just showed you all these amazing mapping surveys, and you're like, how the heck do I get on board? Because this looks like the coolest ship ever. Is that correct? Okay, cool. So there's a couple of different ways that you can get on board. The first and most obvious is to try to do a science project. So this whole process is outlined on the website, so I'm not going to read everything to you. I'm going to give you the gist. So as I said before, we like to really promote people to provide them a platform to do the research that really doesn't get funded commonly from other resources. So technology development or exploration and that sort of thing. So these are sort of the kind of these are the kinds of topics that we encourage people to apply to do on the ship. Now the way it works is you're not applying to us to give you money to do stuff. What you're so like if you want to go on some other university vessel, you have to ask NSF for money or NOAA for money. They give you a pot of money, and then you pay the ship operator for the ship time. So we cut all that out. So you say you want to come on the ship. We say, great, love your project. Here's the ship. You have to provide salaries or any post-processing costs. So if you collect a bunch of water samples, we don't provide any financial assistance to process those after the cruise. So we only provide the ship and the equipment on the ship, and then the rest is up to you guys. So generally the way this works is in the fall, we'll have a call for expressions of interest. So this is where people will submit a 1 to 2 page, short proposal of what they might like to do on the FALKOR, why it would be beneficial to do it on the FALKOR, and we have a committee with outside people in the scientific community that help us sort through all of these projects to find the ones that fit the vision and the mission the most for the company. So they go through that in the first round, and in the last few years on average we've had around, say, 70 or so proposals. So they weed it down to about 25, and then they ask for a full proposal. So really detailing the whole project and the outcomes and the questions and the technology you want to use to acquire your data. And then we have the committee then go through them all again and then really pick the ones that we want to support for that given year. So we look like 2 years ahead on our expressions of interest. So we'll have, say, 8 or so projects per year supported by the ship. So in order to evaluate from the committee, they use these criteria. So, one of the most common ones is, the data sharing. This is weighted pretty heavily because it's really important to the founders that everything is made publicly available. So the groups that show that they really want to make that available, quickly and completely, that's weighted pretty heavily. Also, outreach is a really big part of the program. We want to be able to communicate the science that we're doing to everybody, and we usually sail an outreach person representing SOI or provided by the science party to update the blog so people can read up on the cruise as it's happening, to document with photos and video, and then also to conduct shoreside chats and things with classrooms and museums and aquariums and all that sort of thing. So these are the criteria that are used to evaluate the final proposals, and then once you're selected for the cruise, then that's when it sort of comes onto my plate into our department, where we start planning out, okay, what do we need to get, what do we need to do, how's it going to work. So the second opportunity to get on board, which may or may not be useful for you guys individually, is the Student Opportunity Program. So this just started this past year, and the way this works is on some cruises, particularly mapping cruises, they're not usually quite at capacity for bunk space, or oceanography cruises. It's really hard to do on ROV cruises, but it does happen. When we have extra bunk space, we like to make that available to students so that they can come on board and gain experience being at sea, if maybe they've never been at sea before, or be working with the scientists to conduct a survey or deploy equipment. And then also graduate students can also do their own research if they have something that sort of complements the project that already exists. Something that a student can sort of tag along on what the science group is doing and work with them. So could be undergraduate or graduate students. Currently it's not paid, but I find that something that I encourage in particular undergraduates is, anything you can do to boost your resume, to make you stand out from the other people. Yeah, it might not be paid, but this is a really important experience to have. If you're looking to go into this career, you're much better finding out you do or don't like it as far in advance as you can before you've really dedicated your career to this field. The third way to get on board, if you guys are of an artistic inclination or know anybody, is the Artists at Sea program. And this has just started right now in 2016. And this program really is focused on providing different ways and different perspectives of communicating science to the public. So I don't know if you've noticed, but sometimes for people not in the scientific industry, reading science papers and journals is a little difficult and maybe doesn't make the most sense to them. So having an artist on board is just another way to reach out to the public and educate people about what we're doing, why it matters, why the ocean's important, and all that good stuff. So we try to have folks come on board who have medium other than digital, photo and video, because we have a lot of that covered with our outreach personnel that document the cruise on the blogs, on the website. So we encourage people with sort of other medium to really elaborate more on the science from other perspectives. But the data, the entire reason why we leave the dock in the first place is to collect data. So where do you find it? I think you guys are going to be quite familiar with a lot of these resources. The mapping data goes to NGDC. The oceanography data, like CTDs and the MET data and stuff, goes to NODC. Also through our R2R program and through the SAMOS program, the ADCP data, when they work sometime in the century maybe, that goes to UHDAS. And then also MGDS for our multibeam data, and all of that goes into GeoMap app and then hopefully Google Earth as well. So plenty of ways to find the data. It's it's made available kind of in the depends on the cruise how quickly the scientists want to get it out the door. So it could be a couple of months or it could be a year or two. It kind of depends on each cruise, but eventually it all gets there. So if anybody has any questions, I will take them now.
Where are you guys with respect to telepresence?
That's a great question. So we have done some telepresence, and the way that we did it was broadcasting on our YouTube channel, which was on YouTube and then also embedded on our website. We don't do that for every cruise because obviously it's quite expensive. I think there might be a plan to do some of that in our upcoming ROV cruises. I think that not so many people are particularly interested to watch people staring at computers when conducting mapping surveys. I don't know why not. It's so interesting to me. But I think we tend to do it more when we have vehicles, ROVs and stuff. So we have been, if you talk about telepresence in the sense of communicating with people, we do a lot of outreach aside from actually broadcasting the science live. So we still do via like Google Hangouts or whatnot, a lot of outreach with museums and schools and things, giving them tours of the ship and that sort of stuff.
Live broadcast.
Yeah, I think that.
So the YouTube is not a live broadcast, it's
It will, yeah, it's delayed by, I think it can't be delayed by any more than 60 seconds, otherwise it doesn't work. So it's pretty much
virtually
live.
live.
Yeah, for our intents and purposes, that's live. So that will get announced on the website when we do that. And I'll bring up a web page and I'll show you something interesting. So this is our website, and so usually we'll have the current cruise will be kind of pop up there at the top. Have some, recent information announcements. The latest blogs are usually here. But the thing I'd like to point out is if you just click on FALKOR, you can get the status of the ship. So this is streaming like data as we're underway. So we have our MET data, we have our seawater data. This just shows kind of, where all those sensors are located, where the ship is in the world. Here's some numbers if you want the actual values. And then when we do have the live streaming, we'll have that posted here. So you can see that all on the website.
Could you tell us a little more about your ROV capability?
So in our first year of operation, or first 2 years of operation, we had 3 different ROVs on board. We had Nereus, she rest in peace. We had the Global Explorer from DSSI, and we had Ropos. And the idea there was to try out the different types of vehicles to see which one, is more easily operated from the ship and has greater capabilities and stuff. They then decided they wanted to build, the SOI wanted to build our own ROV, so that's under production right now. And so we have a facility in Hayward, California, where we have a team of engineers designing and building our own ROV that will be on the FALKOR, and that's due to come on the ship in July and go into sea trials this summer in July and August, and then do its first science verification cruise in November, December. But we have Ropos coming on board in March and April.
What kind of depth capabilities that you're going
The first vehicle is going to be 4,000 meters, and then the program is to then it's either 4,000 or 4,500, and then the second vehicle they'd like to do a 6,000, and the third vehicle they'd like to do full ocean depth. So it'll be done kind of in stages.
Is there any ice reinforcing? Would you be happy working at high or negatively at large latitude?
I would love to work at higher latitudes because I'm tired of sweating all the time in the tropics. I know it sounds really stupid standing here in New England, but it'd be nice to just mix it up a little bit. There is not any ice reinforcement, and I think that probably our bigger concern with that is just going to be that the gondola is so far forward. I think we would be really tentative to take that into ice conditions.
Are there any ice reinforced gondolas? I'm not aware of it.
Just a
It's kind of hard to, we actually looked at that in the Ewing era, and the only plausible scenario we could come up with was a way for the gondola to break off and go away without tearing a hole in the bottom of the ship.
With a line on it.
Yeah. Or an RV to just go down with it.
How often are you collecting water column data with multibeams?
It's a great question. I would say that, I mean, my general rule of thumb is if you want to collect it, go ahead and turn it on. You know, now that we have hard drives that have much bigger capacities, it's not such a burden to collect it and store it. So if you want it, go ahead and take it. But at least in the Kongsberg systems, from my experience, if you don't see it in acquisition, you're not really going to see it in the post-processing either. So it's a little bit of a balance of, you know, what you think you're going to get out of it if you're just logging it to log it. But a lot of cases, it's not logged that often unless we start seeing stuff. And then people will turn it on or turn it off. And it's kind of a similar argument to the ROV video discussion where, you know, some people want to log all of the ROV video all of the time, and other people are like, well, where are you going to put that? You know, do you need a 4-hour chunk of videos, the ROVs descending? And some people say yes, you might see some squid or something in the water column, and it's going to be like, you know, the Kraken or whatever, and revolutionize science. Or you may see nothing, and then you have 4 hours of video taking up space. So it's a bit of a balance, and so I leave it up to the scientists. If you want it, log it, do whatever you want to do. Happy to help. But they tend not to do it unless they start seeing stuff. Yeah.
Did I hear a rumor that you were putting a high-end computing cluster on board?
That is not a rumor, that is fact.
Good, okay. So
Yes.
can you tell us about what it's used for, if anything?
Yes. Currently, it's mostly been used for modeling. So we have, you know, might have a cruise that's studying something in particular, like we did the Tasman Sea cruise where they're studying the internal tides. And so they have a model they brought with them, and we're able to add the CTD data as we collected it to update the model and run, you know, crunch the new numbers. I think that it was used, and I wasn't on a cruise, I think it may have also been used for some photo mosaicing from a variety of vehicles. They had a cruise where they had a whole bunch of different gliders and AVs, and I think they may have used it for that as well, but I wasn't on that cruise, so I'm not you know, I don't know the particular details. And I've started the discussion of whether or not it'd be really useful to use for mapping or not, because I still find that even if you do have all these automated processes, you still have to have that human interface to really look at the data and to make sure that, you know, everything is working correctly. So, you know, the mapping data is probably the one set of data that really is always processed on board. You know, it may not be totally clean by the end of the cruise, but it's, you know, the one data set that really stands out as really being complete, you know, by the end of the cruise. So, yeah, so that's available to the scientists if they want to use that. But it does take a bit of support and advanced planning. It's not something we can just say, okay, go ahead and, you know, plug your thumb drive in, you're good to go. You know, we have to do quite a bit of legwork to get that set up for the different purposes. But you can set up any operating system that you want, and then allocate however many cores and thing, you know, space and everything to it. So it's, you know, capable to do quite a bit. Yep.
Just wondering, what's the typical way that visiting scientists fund the rest of the cruise costs? If you're providing the ship, but they have to provide everything else.
Yeah, I think that a lot of it comes from, well, for the Americans anyway, it comes from NSF, and then some others might come from NOAA. The international groups, I'm not really familiar with their particular agencies, but I think that a lot of the salaries, for example, and then the post-processing will be funded that way, or if they have a private organization.
Does that seem to strengthen proposals?
I have heard mixed reviews about it, that it is actually kind of difficult for people to coordinate both sort of sets of grants. So you're trying to get the money from Schmidt Ocean Institute, the money, meaning the ship, and then you're trying to get a grant from somewhere else. And if you can't get one, you can't get the other, then you're kind of stuck. So I have heard that there has been some difficulty in really planning that and getting the timing to really align easily.
I can talk from experience. I've been on
Yeah.
the review panels. The best situation, because NSF kind of decouples the ship time request from the proposal. The proposal is
Yeah.
reviewed. It's it's dangerous if you put an NSF proposal in that says, I'm gonna count on getting Schmidt
Right,
time,
right.
because you don't know.
Right.
But if you're in a situation where you've been funded by NSF already, and it could be a 2 or 3 year wait
Yeah.
for ship time,
Yeah.
and then a proposal, you send your proposal into Schmidt, then that has high likelihood on both sides if it's a good proposal.
Right.
Everything else is funded, so it's good on the Schmidt side.
Right.
And from an NSF perspective, it's a great deal.
Yeah, yeah. Anybody else? Yep.
What's the relative breakdown of international scientists versus US?
You mean from cruise to cruise, or
just
within a
like-
cruise?
Just on average through a field season?
I would say that it really does depend on what part of the world we're operating in, because this past year was very heavily international because we were located in Australia and Indonesia for a good part of the year. So I would say, this past year would have been like 1/3 American, 2/3 international. But other years, like where we were based off of Hawaii for quite a long time and Guam, that was, very nearly entirely American. Same thing with our time in the Gulf of Mexico. So I think that we do have a higher percentage of international scientists within the science party, regardless of whether or not the sort of primary institution is US based or not. So I still think that we have a greater mix, but it largely depends on where we're operating for the year. And the area that we're operating for the year really just depends on which cruises they decide to accept as well. So it's not really planned to be one way or the other.
Well, thank you.